Welcome to this explainer. You know, for the past few years, we've all been absolutely marveling at this first wave of AI. We've got chatbots writing our emails, tools generating mind-blowing images, coding assistants practically doing our jobs for us. It's been wild. But right now, a paradigm shift of massive proportions is quietly occurring behind the scenes. We are actively transitioning from an era where AI simply generates content to an entirely new era where AI takes autonomous action in the real world.
Think about that for just a second. What if the AI we use today is really only the beginning? Experts across the tech world are pointing to a looming transformation, one that might actually change our society, our businesses, and our daily lives more dramatically than the internet, smartphones, or honestly, even electricity. We are talking about a massive leap from tools that just sit there waiting for our instructions to dynamic systems that operate completely independently. Let's dive right in. Professor Sinan Aral over at MIT Sloan really hit the nail on the head. He says the agentic AI age is already here, and that we have agents deployed at scale in the economy right now. This isn't science fiction anymore, and it's definitely no longer just some laboratory experiment. Looking toward 2026, the shift from experimental AI to autonomous reality has effectively already happened. The infrastructure is built, the models are trained, and they are actively running incredibly complex workflows as we speak.
Section 1. Generative versus agentic AI. The leap from creation to action.
So the contrast here is pretty stark. Think of generative AI as completely prompt-dependent. It relies on a human sitting at a keyboard. You ask it to summarize a financial report, and boom, it gives you a summary. It creates, but it doesn't do. Agentic AI, on the other hand, is goal-driven. It's autonomous. If you hand an agentic AI a goal in business management or finance, it doesn't just write a draft for you. It autonomously gathers transactional data across a bunch of different databases, reconciles any discrepancies entirely on its own, submits the required regulatory filings, and then just hands you a final report of what it already accomplished. It executes multi-step tasks from start to finish.
Okay, so how do these agents actually work behind the scenes? Well, it's basically a continuous loop which breaks down into three main steps. First up is perception. The agent takes in data through APIs, digital sensors, or real-world inputs. Second is reasoning. This is where it uses large language models to actually think. It plans, it breaks a massive goal down into smaller subtasks, and evaluates its options, honestly, just like a human manager would. And third is action. It actually executes the task using software tools or even physical robotics. Once it acts, it perceives the result of that action, and the whole loop starts all over again.
Moving on to Section 2, the 2026 Edge, Power in Your Pocket.
The hardware reality we are looking at for 2026 is, frankly, staggering. Just look at the immense processing power, measured in trillions of operations per second, or TOPS, that's now standard in everyday consumer devices. We've got the Apple M4 chip pushing 38 TOPS, and the Snapdragon 8 Gen 4 hitting 45 TOPS. And because of this brilliant software optimization technique called quantization, which essentially shrinks these massive AI brains down without losing their smarts, incredibly powerful models now fit perfectly into the 16 to 24 gigabytes of RAM on your everyday laptop or phone. You literally no longer need a massive cloud supercomputer to run advanced AI. You just need the smartphone in your pocket.
Now, you might be wondering, why does running AI locally on your device matter so much? Well, first and foremost, privacy and data sovereignty. When the AI runs locally on your laptop, your highly sensitive medical, legal, or personal data never actually leaves your device. There's no cloud API logging your personal queries. Second, zero network latency. You don't have to wait for a server halfway across the country to respond. It is instantaneous. Third, offline capability. These agents can work on an airplane, out in a remote field location, or during a massive network outage. And finally, it drastically reduces cloud computing costs for developers operating at scale. It's a real game changer.
Section 3. Physical AI. The world is the interface.
So, neuro-symbolic integration. It sounds like a mouthful, but it's basically the cutting-edge architecture that makes physical AI possible. By using frameworks like physical RAG, this architecture allows an AI to take abstract cognitive reasoning, the kind of thinking an LLM does, and map it directly onto physical robotic actions in real time. And it does this safely and predictably. It entirely bridges the gap between digital thoughts and physical movements.
And we're already seeing physical AI actively transforming critical industries. In the energy sector, embodied agents like drones are autonomously monitoring miles of pipeline, detecting anomalies, and making repair decisions completely on the fly. Over in manufacturing, smart factory robots are using advanced vision models to spot microscopic defects and literally adopt the assembly line in real time. In healthcare, it's enabling unbelievable robotic surgical precision that's tailored directly to real-time patient data. And in agriculture, spectral imaging models allow AI to autonomously analyze crop health and instantly optimize irrigation. The AI is observing, deciding, and acting directly in the physical world.
Section 4. The Climate Handprint. Planetary Scale Impact.
Now there's a highly publicized, and sometimes debated, dual narrative surrounding AI and the climate. But impartially speaking, the data shows two things are true at the exact same time. Yes, the massive data centers required to train these AI models demand an absolutely incredible amount of electricity. That's a fact. However, AI is simultaneously acting as a remarkably powerful optimizer for our energy grids. It's accelerating the transition to clean energy faster than public policy alone ever could, simply by actively balancing supply, demand, and intermittent renewable sources.
In fact, recent extensive research highlights a number that is just stunning: an estimated 5.4 gigatons of avoided emissions by 2035. How is that even possible? Well, because AI's handprint, meaning its ability to optimize global logistics, discover new sustainable materials, and drive circular economies, far outweighs the carbon footprint of its data centers. For example, machine learning is actively discovering sustainable substitutes for highly carbon-intensive materials like cement in a mere fraction of the time it would take human researchers.
Furthermore, this voracious energy appetite of AI is actually creating an immense market pull. We are projected to see a 4x surge in the use of high renewable energy by the tech sector over just the next 3 years. These massive tech companies are essentially forcing the energy market to innovate and build clean energy infrastructure at a totally unprecedented rate just to power their AI ambitions.
But, and this is a big but, the sheer scale of these modern data centers exposes a massive execution gap leading into 2027. The demand for AI power is vastly outpacing our physical infrastructure. To actually realize AI's sustainable promise, we have to solve severe bottlenecks in grid connectivity, permitting, and financing, and we have to do it over the next 24 months.
Which brings us to Section 5, the challenges of autonomy, navigating risk. We absolutely have to take an objective look at the vulnerabilities facing this rapidly evolving tech. I mean, when an AI generates a hallucination in a draft email, it's annoying. But if an autonomous agent hallucinates while executing a high-frequency financial trade or acts on an underlying bias while adjusting a patient's medical dosage, that is a crisis. These systems are also highly vulnerable to prompt injection attacks, where malicious actors trick the agent into leaking secure data. Add to that a messy landscape of regulatory uncertainty and the very real human psychological danger of over-trusting these machines to be infallible, and it becomes crystal clear: robust governance is absolutely crucial here.
Section 6, 2035. Thriving in an AI future.
The core message here is actually incredibly profound. We are heading toward a society of smart cities, hyper-personalized education perfectly tailored to every single student's unique learning style, and deep human-machine collaboration. Apocalyptic predictions rarely actually come true. Instead, the future won't belong to those who fear AI. It's going to belong to those who understand it, adapt to it, and learn how to work alongside it. Preparation matters so much more than prediction. As AI completely takes over routine tasks and complex executions, the value of uniquely human skills is literally going to skyrocket. The future workplace isn't about competing with AI, it's entirely about collaborating with it. Skills like pure creativity, critical thinking to evaluate a complex AI plan, human leadership, adaptability in rapidly changing environments, and deep emotional intelligence. These will be the ultimate currency of the future. You are essentially going to act as the manager, guiding and collaborating with a team of highly capable AI agents.
Which brings us to our final, kind of lingering thought for today. We've seen how these autonomous systems are going to reshape healthcare, agriculture, the energy grid, the whole shebang. But zoom in on your own life for a minute. The technology is already here, it's running locally right on the devices in your pocket, and it's ready to take action on your behalf. So I'll leave you with this question. If you could have one advanced AI assistant helping you every single day, what would you ask it to do?